Welcome to the DIY Honda Garage channel. The diagnostic trouble code P06A8, identified as an internal VCC power malfunction, primarily involves issues within the powertrain control module, or PCM, of the Honda Accord models produced between 2012 and 2017. This particular error is linked to the PCM's internal 5-volt power supply, which is crucial for the entire engine management system to function correctly. When the PCM monitors the internal 5-volt supply against a reference AD input power supply voltage of 3.45 volts, a malfunction triggers a diagnostic code if discrepancies occur. Essentially, if the 5-volt power supply is not performing as expected, and the reference voltage exceeds acceptable thresholds for more than 2 seconds, the PCM identifies this as a fault, thus establishing the P06A8 code. This is indicative of potential failures in the PCM itself or associated power supply circuits. Identifying and addressing this issue promptly is critical to maintaining engine performance and preventing further damage or diagnostic complications in the vehicle. In summary, DTC P06A8 signifies an internal VCC power malfunction within the Honda Accord's PCM, which plays a crucial role in managing engine operations. Understanding the roles of both the 5-volt power supply and the reference AD input voltage of 3.45 volts is crucial for diagnosing the issue effectively. The troubleshooting process entails verifying ignition conditions, testing voltage levels, and inspecting power supply circuits. This thorough investigation is essential for pinpointing the cause and executing proper repairs. Preventive maintenance practices, including regular inspections of related circuits, can help mitigate future issues. Ultimately, proper diagnosis and timely intervention are key to maintaining the efficiency and reliability of the engine management system, ensuring long-term vehicle performance. The primary component affected by the P06A8 code is the powertrain control module, commonly referred to as PCM. This module is vital, as it manages crucial engine functions by processing input signals from various sensors. Situated typically within the engine compartment, the PCM relies on its internal 5-volt power supply to operate effectively. When there is a malfunction in this power supply, the PCM cannot accurately compare the internal voltage levels, leading to erroneous signals and potentially unsafe driving conditions. The function of the AD, analog to digital, input power supply, which acts as a reference voltage of 3.45 volts, is to ensure that the 5-volt supply is functioning within normal parameters. If this comparison indicates that the voltages are outside their designated ranges, the PCM flags this as a malfunction, subsequently logging the DTC P06A8. This shows the significance of the PCM and its internal 5-volt supply in overall vehicle performance. When diagnosing the P06A8 error, 2 leading possible causes must be considered. The first is the failure of the PCM's internal 5-volt power supply circuit. This internal circuit is pivotal, as it feeds the necessary power to various engine management functions. If this circuit fails, the PCM will struggle to maintain stable voltage levels, triggering the diagnostic trouble code. The second possible cause is a failing 3.45-volt power supply circuit. This circuit serves as a benchmark for the PCM, making it essential for the proper functioning of the internal systems. An issue in this circuit can result in incorrect voltage readings and lead to the logging of the DTC. It's crucial to perform a detailed examination of both circuits to determine the root cause effectively and ensure all issues are rectified. Symptoms related to DTC P06A8 can manifest in several noticeable ways, primarily indicating problems with vehicle performance. One of the most significant signs is the illumination of the malfunction indicator light, or MIL, on the dashboard, alerting the driver to a potential issue that needs addressing. Accompanying the MIL, there may be observable engine performance issues, such as rough idling, stalling, or poor acceleration. These symptoms occur due to the PCM's inability to manage engine functions accurately when its operational powers are compromised. Additionally, when mechanics interface with OBD, onboard diagnostics tools, they will find that this DTC, along with possibly other diagnostic trouble codes, have been stored in the system. It is essential for drivers and technicians alike to be alert to these symptoms, as they suggest that the vehicle's engine management systems are not functioning as they should. The first step in troubleshooting the P06A8 code is to ensure that the conditions for DTC monitoring are met. This means verifying that the ignition switch is turned to the on position. In vehicles equipped with keyless access systems, this typically involves ensuring that the engine start button is also set to the on mode. It is crucial to accomplish this step, as the PCM only initializes its diagnostic checks when these ignition conditions are satisfied. If the ignition is not correctly engaged, the PCM will not perform its monitoring functions, leading to a false assessment of the internal power supply status. Thus, confirming this setup is fundamental before proceeding to more elaborate diagnostics to avoid unnecessary troubleshooting steps later on. The second step in tackling the P06A8 issue is to conduct tests on the PCM's internal power supply. This involves measuring the voltage levels supplied to the PCM, specifically checking to see if the levels fall within the expected range for normal operation. The internal power supply should maintain a steady output of 5 volts. Anything less than this could indicate a malfunction. Utilizing a multimeter is essential in this process to obtain accurate voltage readings effectively. Furthermore, it is crucial to ascertain whether the reference AD input power supply voltage of 3.45 volts is also functioning correctly. If either voltage measurement is outside acceptable parameters, the technician can deduce that a power supply problem exists within the PCM. Documenting these measurements is vital for understanding the workings of the vehicle's engine management system and determining the next steps in the troubleshooting process. Following the voltage testing, the third troubleshooting step involves inspecting the power supply circuit itself. Technicians must physically examine the wiring and connectors linked to both the PCM and the 3.45 volt power supply circuit. This inspection is crucial because broken, frayed, or corroded wires can disrupt the power flow, leading to erroneous voltage readings and potential DTC codes like P06A8. Focus should be on ensuring that all connectors are seated properly, without signs of dirt or corrosion, which could impede connectivity and affect performance. Any faults discovered during this examination should be rectified. Failure to do so means the underlying issue could persist. By ensuring the integrity of the power supply circuit, technicians can establish a strong foundation for the proper functioning of the engine management system. After executing repairs regarding the P06A8 diagnostic code, the final step involves verifying the integrity of the work performed. To begin, technicians should clear any diagnostic trouble codes from the PCM to reset the system. Next, it is crucial to rerun diagnostic checks to ensure that the previously noted issues no longer exist. This follow-up serves as a confirmation that the repairs have resolved the internal power supply malfunction, allowing the PCM to function correctly without triggering DTC P06A8 again. If the diagnostic checks indicate all systems are clear, it is a strong indication that the intervention was successful. It's important to emphasize the necessity of this verification step. as overlooking it can lead to unresolved issues and further complications down the line. Preventive maintenance is vital in avoiding the recurrence of issues that trigger DTC P06A8. One of the key practices is conducting regular inspections of the vehicle's wiring and power supply circuits. This includes looking for signs of wear, corrosion, or external damage that could lead to failures in the system. Additionally, ensuring that diagnostics are run regularly can highlight any emerging issues before they escalate into major faults. Keeping the PCM updated with the latest software can also mitigate potential problems that arise from outdated programming. These maintenance actions not only help in extending the life of the vehicle's components, but also contribute to overall engine performance, leading to a more reliable and efficient driving experience. Please like and subscribe to the channel. See you next time.